Okay, today I'm going to talk about function. We'll learn about several built-in functions which were already built in MATLAB. But in this module, we'll learn about how to define our own custom function. I'm going to talk about the syntax of the function and its working process. At the end of these lectures, you can explain why we define and use function in programming. You can create and design the functions to support the different numbers of the input variable and output variable. There are local and main functions depending on their placement in the file. You can tell their difference. You can identify the variable scope or workspace when the script includes the script and local function. Finally, you can program your own function. Okay, what is the function? You already experienced the power of the built-in function, right? Function is the types of the procedure or routine that perform the specific task. Okay, think about the sum function. Okay, and think about what kind of the task that conducted in the sum function. Okay, depending on the input argument, you can perform the predefined operation using simple one-line script. That's the function. Okay, similarly, we can build our own function. Why? It can be more organized and reusable. Okay, that's the reason why we use the function. Okay, again, almost all basic operations were already organized and packed as a built-in function in MATLAB. But we need to build our own custom function to solve the actual problem. Okay. What's the advantage? The biggest advantage is organized and readable. Okay. Rather than looking at the long and messy if loop and an if statement, you can use only one line that's more readable. So recall that when you let's say there is a matrix. If you add all the elements in the horizontal direction, you need to initialize the loop, initialize the column vector, and then make a double loop structure, and then adding the all element each row, right? Rather than this operation, you can simply write a one line to this operation. So that's much more organized, that's much more readable, rather than the putting into this long, multiple lines, a combination of the if and the loop statement. Okay. Another benefit is the time saving. Okay. Rather than putting in this messy the loop and then a statement, if you can make the one single line, you can easily debug your code. Because of this code, you can trust this operation inside of this built-in function or the function you define, and then you can find the error or mistake the other place. Okay, make sense? Okay, good. There are various types of the function. You can design function like a single input and single output. For instance, absolute function, we accept the one single numeric value, output is the one single value. Okay, or the multiple input and single output. It's like a random I. So randomly generate the vector. Okay, in that case you need to put the range and then size, right? This case a multiple input and then one output. Okay, But the normally built-in functions support the various forms like a single input and a multiple output, or the multiple input or the multiple output. So like a size comment, okay? So if you want you only identify the column size, right? But if you without the second argument, so we can get this two-dimensional. So first and the second dimension of the method one. Okay. But sometimes we use the function that does not return the output, like a display. Okay. Displays a function is to display your variable in the command window, right? In the script, this function does not return anything, right? Okay, it only print out this value. Okay. Okay. Here's the example. You're familiar with this sum function. Okay. There are many syntax. These are many syntax like this. Okay. And this sum function support this various types of this input argument and the corresponding the output value. Okay, we covered this three, right? Okay, depending on this second argument, they're doing the different operation. Okay, make sense? Okay, so this is the syntax for defining function in MATLAB. Okay, the text in red must be included to define the function, except for in the special cases. Okay, let's see the one by one. The function header at line 1, they include the function. This one is the reserved word. And then your output argument. Output argument is the variable that you're going to assign the output value. Okay. If there are more than one, they're separated with a comma. For instance, in the size built-in function, we are separating, with a column. Okay. But this one is so the way of the calling your function, but when you define the function, the output argument is the same way. Okay. I'll show the example later. Okay. But only exception is if the function has only one output, you don't need this square bracket. Okay. Only one output, there's no square bracket. And you don't need to put the square bracket, I'll say. Okay. Then equal sign. Then you can put your mnemonic function names like a sum, max, or mean. Okay. I normally use the capital letter in each word in a function name because I'll differentiate it from the other variable. For instance, compute num character, okay, or calculate vector length, something like that. Okay. This is important to use the numeric variable. Do not use the tom or AAST or something like that. Okay, I already mentioned in the module 2, right? The similar way. Okay. The rule of the making this function name is following the rule of the making the variable name. So you cannot put the symbol except for this underscore. Okay. Good. And then put the input argument inside the parentheses. Okay. If there's more than one input argument, you can separate with a comma. Okay. So basically, function accept the input argument. Okay. And your script part is to calculated your output arguments using the input argument. That's why your script must include assigning the output value to this output variable. That's obvious. Okay, finally, the syntax is finished with and. Okay, that's the syntax of the defining the function. Okay. Here are some notes on the function. So when we call or use the function, of course the name should be the matched. Okay, that's a case sensitive. For instance, when you use the size function, that is a built-in function, but the way of the using this custom function is exactly same with the use of the built-in function. When you use the size, you should not call the function is this size with a capital letter, because these are the case sensitive. Okay, and the number of the input variable, input arguments must be the same. The number of a variable placed in the output, the left-hand side of the function should be the same. I'm just making example using this size built-in function, okay, because we are familiar with. Okay, let's say we are making the math A. You should not make the like this, okay, because this one is indicating the producing the only one output argument or an output return, but you should not place as two. Then here's the example. We define the function called fnName, and then 2 input argument and 3 output argument. Okay. Basically, this function is computing the xyz using the a and b. Okay. When you use this function, for instance, like this one. Okay, this one is defining the function. This one is how to call function. Okay. When you call the function like this, the meaning is 11 is assigned to the A, 4.3 assigned to the B. And then this the script inside of this function, inside of the function, that compute the xyz value using the 11 and the 4.3. Okay, the final outcome of the xyz from the functions are assigned to the GHT. Okay, that's how it works. Okay, again, this one is how to call the function. This one is how to define the function. It's like not define the function, it's like a function header. Okay, then you need to have this script to compute the xyz. Okay, does it make sense? And when you call this a function, you can use any output variable name. It doesn't have to be matched to xyz. Okay, think about when you use the size function, you can put any variable name, right? Make sense? Okay. Okay, here's a very simple example. We'll learn about the absolute function and how to make this operation using the if statement or the relational operator. Okay, similar to the absolute function, how to make our own absolute function to replicate this same operation. Okay, here's the script that we already worked on. So for instance, here S1 is 3. If S1 is more than 0, S2, absolute value of the S1 is the same with S1. S1 is less than 0. You need to multiply the minus 1. Okay, that's the operation. So how to make this function is very similar. Start with a function that is a visual word. Okay, and then you can put any output variable name. So one output variable, right? One output argument. Okay. The input is let's say x. Okay. Your function name is the my absolute. Okay. Then put this script here. Okay. Only difference is here we're processing this script using the given input. S1 is a 3, but here we haven't given the input value. Okay, input value is later we assign the input value when we call this a function. We are developing this script using this x. Okay, so here's your script. Okay, but here there's no bracket, square bracket. Why? Only one argument. Okay. But different from the output argument, input argument, you need to always put this parenthesis. Okay. Make sense? Okay, do the same process, but here the output value should be the XAB. Okay, because this should be, that is the output argument, right? Okay, and then here's the how we call this function. Okay, it's very similar to the built-in function. Okay, S1 is assigned as a -3 assigned to the S1, and then if you put the S1 to the my absolute value, then it give you the absolute value of the S1. Or you can simply like this. Okay, they're exactly same. Okay. The way we call this custom built custom function is the exactly same with the calling the built-in function. Does this make sense? That's simple, right? Okay, here I'd like to mention the difference between the script and function. They are totally different. Okay, the script is the place that we write a series of the command, which is what we have done so far. Script needs to include the input or a code to read the input data from the output file. That's the script. The script is not accepting the input. Okay. On the other hand, the function is to accept the input, and the output will be vary depending on the input. The functions and scripts are using own workspace. In other words, they use the separate workspace. That's the major difference. I'll talk about what is the workspace, what separate workspace mean. Okay. Here's the example. When you watch the tutorial video, every time I store my script in the computer, that's the script. Okay. So given the input is generated from the random built-in function, right? Or I specifically give the input, right? Manually write the input value, right? And then we can compute the output, right? So to compute the output, you need to have a series of the operation or processing, right? That's the script. However, if we use the function, the entire or some of the input are sent to function and then do processing, and then function send the output back to your script. Okay. Here, I said when the script called the function, the only input is sent to the function, right? So not all the value. So the function cannot use any variable defined in the script except for the input variable that is the given. Okay. Okay, I'll revisit this topic later. But here's some brief, description. Here, input and output, series of the processing. So basically, we given the input something in the script, and then series of the processing using the input, and we get the output. The process of using the function is a little bit different. Input data, when this input data is sent to the function by calling the function, right? And then they return the output, okay? Like this. Makes sense? But here, so when we use the script, all this your script, your code is stored in your one single M file, right? Do you remember the way I did in the tutorial video? But if you use the function and my script are stored in the separate file. Okay? Here's how we store the function. Okay? Function is stored in the code file. It's the extension of the .m file. It's the same. Your script is stored in the M file. The function also stored in the M file. The file name must be the same as the function name. Okay. For instance, here. So we copy this, we write this code to your script window, and then store as my abs.m. Make sense? Okay. Must be the same as the function name. Okay. The file that contains the function should be placed at the same folder as the script used the function. Okay. For instance, you make this myabs.m file. Okay. When you call this a function in your script, so input value out equal to my abs. If you try to call this a function in your script, this is a script file, my script.m, and then this is my absolute.m should be placed in the same folder. Okay. Otherwise, you need to add this script folder to search in its path. That is called add path. But at this point, please store your function file in the same folder. Okay, I already mentioned this how we called this function. But here's some screenshot of the way of using this kind of the function. Okay, I stored this my abs function in the myabs.m file. Okay, I also store this script that calls this my absolute function in the same folder. So see this? These are the current directory. This is the file inside of this current directory. There's the two file, my script and the my absolute. So see this? fx means function. Okay. Both are the place at the same folder. Okay. Then my script called my absolute function here. Okay. If the my absolute.m is a place in the other folder, we cannot call this function. Again, if you're calling the function in the place in the other folder, we need to use add path. But at this time, place your function at the same folder. Make sense? So let's start with the problem that we are familiar with, the bulls and cow. Okay, I'm not repeat the rule of the bulls and cow again. Okay, how to write a function to compute bool? to compute bool, what's the input? True and test the number, right? What's the output? Of course, that's the numbers of the bool, right? We already coded this script to compute the bool in the module 6, right? Using the operator. Okay. Okay, how to make the function? Okay. But here, so the function name is already given, compute bool. Okay. And then function compute bool. What is the input? Two input. This one is a true number, test number. Okay. And then we are computing the numbers of the bool. Okay. Again, you can use any variable name to compute your output. Why? Think about the mathematical function. If you define your function like this, what about this one? That is a 4, right? What about this one? Okay. What is this one? That is the 4, right? Same. Okay. This one is a similar. You can use any variable name in your function, so like x and y. It doesn't matter because your output, the way of the computing the output using this input are exactly the same, right? Make sense? So here's the code to compute the bool, numbers of the bool. Okay, and then we store this compute bool in the separate m file. The name should be matched with your function name, compute bool.m. Okay, in your script, in the separate file, then you call this function by inputting this true and then test number. That you finally get the numbers of the bool. Do you understand this process? Okay. Again, this compute bool.m, myscript.m are stored in the different file. Okay. So we can make the function to compute the cow. The way of the computing the cow is to first identify the numbers of the digit overlap and then subtract the bools from it, which is the digit at the same location. Okay. This part is the compute the bool plus cow, right? And then this one is the computing the bool. Okay, oh no. Right? Finally, the numbers of the cow is the subtracting the numbers of the bool from the numbers of the C. This one is a bool plus cow. Okay, makes sense. So basically, the way of the making this function is exactly same, very similar to this compute the bool. You can develop your script using the two input. The only difference is that we are not assigning this input value, okay, to define the function. So you make this script, and finally you can get the cow. Okay. If you're still confused with this code, please take a look at the slide in the previous model. Okay. But here, this part. So we already made this a function to compute the bool in the previous example, right? This one, right? So we can reuse this compute bool function. So I already mentioned that that's the main advantage of the use of the function, right? This is a reusability, right? rather than writing this script again, we can reuse this function. Okay, so this script can be written by including this compute the bool. Okay, so here. Does it make sense? Okay. So I'll mention that this is a very simple example. So you can save only the one line, right? This is 2 lines, this one is 1 line. But if you can make the very complex operation, this one is getting longer and longer. If you replace it by this kind of your custom function or the built-in function, you can save a lot of the space in your script, and also your code is much more readable. Okay. Then finally, how to make the code to compute both the bulls and cow. Okay. In this case, our inputs are the same, right? True, and then test the number sequence named x true and x test. Okay. What is the output? Bulls and cow. That's why there's 2 output. So we need to use this square bracket. Okay. And then we can call the function that we already made, compute bull and compute cow. So we reused this compute bull and compute cow, right? And then get the bulls and cow. Okay. So basically, this one is this a compute cow, compute bull, compute bulls and cow, compute BC is stored in the separate file, and then calling this a function in the compute BC. Okay, let's see the more complex example. Given a character vector names of one character, so write a function to check if one character is in the English alphabet. If yes, the true is assigned to the is alpha, otherwise a false. Okay, but you need to make sure that you can solve this problems. I mean, you can write a script using the what we learned in the previous model. Okay, so we have done so many practice to solve this types of the problem, right? Okay, how to solve this? First, you need to change this character to the double. Okay, and then evaluate 2 condition statement. One is this character lies in the uppercase or the lowercase. That is a condition 1 and 2. And then is alpha to become an output of the or condition 1 and condition 2, right? This is just a script. Okay. Similar to the bulls and cow problem, we can simply copy this code and place the inside of the function. Only change is you can make the numeric function name, check English character, and then you assign the input variable. Then your output variable is computed using this input variable. So like this. Okay. So basically, the function, when you call this function, you can, send this input data, and then you can get the is alpha. So if you're sending the, A, for instance, this is the value A, you will get true in this case. Okay? Okay. Okay, now we are going to solve the different problem. Okay? Given a character vector, name the character vector. So write a script to count the numbers of the English alphabet. This one case is a write a script, not the function. Okay, script the numbers of the English alphabet character in the character vector. Okay, assign the number to the num alpha. Okay, how to write a plain script? It's like this. Okay, how to start this problem? First, we need to count the numbers of the character, and then make a loop statement with the iterator ranging from the 1 to numbers of the character. Then read each character, and then evaluating to see if this character is English alphabet or not. Okay, that's the, let's say, programming logic, like this one. Okay, this one is the alphabet, English alphabet. You're increasing the value is num alpha. Okay, but here we already program this part using the function, right? This one, right? So we can replace this operation using our check English character function like this. Okay, so here we can put the one single character in our custom function. It gives it is alpha. So 1 is input is English character, 0 is a non-English character. Okay, then you can count the numbers of the alpha. Okay, so what do you think? This one, this one, this one, and this one. So we can significantly shorten your code. And then for me, I don't know what do you think, but for me, it's much more readable. Okay, it's obvious, right? You don't know what this process is unless you look into this script is a line by line. But this one is obvious, right? So check English character. Oh, this one line, this part is checking this character value is the English character or not, right? This one, that's why we are using the function. Make sense? Okay. So how about this problem? This question is to check if the vector contained the English alphabet character or not. Okay, the scripts are with the same operations like a previous example. We first compute the number of character and then make a loop statement with the iterator is a 1, 2 numbers of the character. Okay, the is all alpha is initially set to true, but read the characters, and then if the character is not the English character, you assign the false and then break. Okay, this means if there is at least one non-English alphabet in your sequence, that character vector is not a vector that only contained English alphabet character, right? Okay, makes sense? Again, this operation, we can reuse our custom function, right? This one is repeated. Okay, we can replace this operation, this setup this script with a check English character. Okay, then you will get this one. This is to shorten your code and then much more readable. Make sense? Of course, there are many different ways to solve this problem. Okay, And we could use the existing built-in function, or simply we use the operator. Okay, but this example is just to show that you can reuse your custom function. And then if you reuse your custom function, your script is much more readable and you can shorten your time for debugging. Make sense? Okay. Yeah, this is the very interesting part. Okay, let's see the function that we coded. This one. Okay. So we originally designed the function supporting for one single character, but we could evaluate the character vector because our relational operator and this built-in function, logical built-in function, can support array input. Imagine that you put the array here, it's like a character vector. Condition 1 and condition 2 become a logical vector where 1 is the location where condition statement is true, otherwise a 0. So finally, is alpha become a logical vector. F character in is the character vector. Does it make sense? Okay. Let's go back to the previous two problems. We can vectorize the code without using the loop statement. We can directly put your character vector to here, and the is alpha contain the logical vector where the 1 is the location of the English alphabet, 0 is the non-English character. Okay? So numbers of the English alphabets can be simply computed by the summing up is alpha. So all 1 in the is alpha, right? So this code is shortened as like this by using the character English checked English character custom function. We can shorten this script like this. Does it make sense? Okay. What about the second problem? This one is just to check that is alpha contained all English alphabet character. We can use this all built-in function. Okay, is alpha is contained all the 1. This to give you the 1. Otherwise a 0. Okay. Do you understand that this is the beauty of this function and the vectorization? This is a very good example. Okay, make sense? Okay, good.